Hey there, ladies and gentlemen. Welcome to 5.4. We're going to talk about complex numbers. I do have this broken up. We're going to have part of the lesson in this video, and then the other part you'll either get in a video or we'll talk about in class. All right, so let's talk about product and quotient properties of square roots. So when we look at these, it's saying if you have a number under a square root, you can split it up into two factors. Or if you have a fraction underneath a square root, you can split that up. So there's two ways to look at this. So like if we look at the multiplication one, if I have something like square root of 12, well, square root of 12 is not a perfect square, but I can split it into a perfect square and leftovers. So what two factors multiply to 12? 4 and 3. So here's what I can do is break it apart into the square root of 4 times the square root of 3. And the square root of 4 is 2, and then square root of 3. So this is the same as if you would have done 12 and broke it down into 2 and 6, and then into 2 and 3, and said, hey, 2 times 2 times 3, I have a pair here. Really, 2 times 2 is 4, so it's the same thing as what we're doing up there. And then we get 2 square root of 3. Same idea here. All right. Likewise, I can take two square roots and I can multiply them. So like square root of 2 times square root of 8. I can now put these underneath the same square root, and this becomes square root of 16, which is a perfect square root at 4. Okay, so if you need to, please remember, pause the video to jot some of this stuff down. Same idea here with radicals. That have fractions underneath them. So I can take if I have square root of 3 over 4, 3/4, I can change this into square root of 3 over square root of 4. And we don't keep square roots in the denominator, but this one happens to be a perfect square root, so awesome. We get it like that. Same thing as if I have square root of 27 over 3. I could just simplify by, oh, actually, give me a second. I'm going to put it back I'm going to say, hey, if I have square root of 27 over square root of 3, I can put those under the same square root. And what's 27 divided by 3? Yeah, that gives me 9, and 9 is a perfect square root. We did look at rationalizing the denominators briefly last year. So if you had something like this, you could have multiplied by the square root of 3 to the top and the bottom. The bottom is really where I'm going to focus. You get square root of 9, and the square root of 9 is 3. So we would have ended up with 9 here. And 9 divided by 3 we get there. So take a moment, pause the video so you can get those things jotted down. And then we just have a little reminder here. This is in right underneath, same idea. There we go. So right underneath yours, it says simplified square roots. Expressions do not have radicals in the denominator. Any number remaining under the square root has no perfect square factor other than 1. So it just goes back to what I was just looking at with you. All right, don't forget, it's really helpful to know your perfect square roots. Those are these red numbers here in the middle. So if you don't know your perfect square roots, you will want to jot them down. I have them written over here on the side. So maybe put this in a special spot, in a notebook, on a piece of paper, inside your binder, anything like that. All right, so simplifying square roots. We have done these, we broke them down into all their factors, but now I want you to think about what's the highest perfect square that I can factor out. So 50 is going to break into 25 and 2. And we get square root of 25. Square root of 2, well, square root of 25 is 5. Okay, so if you don't care for this method, maybe you're not that great at your perfect square roots, that's just fine. Write out all your factors. Doesn't matter to me. Do what works best for you guys. All right. 45. So I'm looking for a perfect square root, the largest perfect square root I can divide out. I see I have 9 there, and nothing else is going to divide evenly. So 9 and 5. So I'm going to square root of 9 times 5. we end up with 3 square root of 5. All right, let's go ahead and look at our next one. So 128. So look at your perfect square roots and see if you have something that divides nicely into the 128. And I see 64 here. Again, you can do your factors out. That's just fine. But if you're pretty decent about your multiplication, you should probably, or you will probably start picking up on these things and what multiplies. So you'll get there. All right, square root of x. Ooh, so here we threw in a variable, and that's fine. This is just thinking about like, hey, this is really x times x. So here we have a pair. So, oops, I don't want a square root now. We just get an x. So the thing to think about with variables is if it's even, we're just going to divide it by 2. So that's really nice. If it's odd, we're just going to have an extra one there, and we'll see that here. If we look at E, we see we have some more variables with it. 25 is a perfect square root, and we get 5. X squared we just talked about, we just saw, and we can see down here is x. So y to the 4th, really we're thinking about 4 y's underneath that radical. And if you think back to how many pairs do I have? Well, I have y squared. Okay. Let's look here at f. Now this is a thing, we can divide the fraction inside, or you can think about splitting it. Well, if you think about splitting it, the denominator still has a variable with a radical, and it doesn't simplify. So it's easier for you if you leave it and take x squared divided by x. So that really is this. So now we're left with just square root of x. All right, let's jump to the back side of our notes and take a look here at G. 11 divided by 49 doesn't simplify, but we can break it apart, and 49 is a perfect square root. So we get square root of 11 over 7. I feel like I'm missing a problem on this page, but we'll see. Oh, nope, good. All right, H, same idea, 32 over 81. Can't really divide those, so we're just going to break it up into 32, and square root of 81 is going to give me 9. Now pay attention, square root of 32 though, we can break that down. Square root of 32 is going to break down, I'm just going to jot up here, into 16 times 2. And square root of 16 is a perfect root, so we get 4 square root of 2 over 9. This is our answer for this problem, but anytime you're looking at problems like this, we do always want to check to see if those two pieces there would reduce. And there's no number that goes into both 4 and 9 that we can simplify it with. All right, so let's go ahead and bring out this problem here. Here we do have 32 over 8. That does divide nicely. 32 divided by 8 leaves us with 4. Okay, and 4 is a perfect radical, a perfect square root, so that gives us 2. And the x is not, so that stays underneath our radical. All right, so I know that that was many problems. It should mostly be review from Algebra 1. If it's something that you ran into that you're like, oh, I don't get how you did this problem or something like that, reach out, shoot me an email, especially now. It's so important that you're informing me when you have some questions. All right, square root property. We're going to just do a few problems here, and then we'll end there for the day. All right, so for any real number n, if x squared equals n, then x equals plus or minus the square root of n. So what this is saying is, hey, if I have x squared equals n and I take the square root on both sides to cancel out my square, I really technically get the positive and negative of the square root of n. And let's look here at my first problem. If we want to solve this, I'm going to show you two different ways about this. If we look at it and we say, hey, think of factoring from the last unit, we get x plus 5 and x minus 5 equals 0. So if we use our zero product property, x plus 5 equals 0, so we get x equals negative 5. And if we have x minus 5 equals 0 here, we get x equals positive 5. Now you can think about it if this was an equation. So another way to solve this, and this is what the square root property is saying. So if I add 25 to both sides, and I have x squared equals 25, to get rid of the squared and get x by itself, I take the square root on both sides. That cancels my squared. So I get x equals, well, the square root of 25 is 5, but we really are going to say plus minus 5. And here's why. The green one is part evidence of why we say the positive and then the negative. But also think about it this way. 5 times 5 is 25. But negative 5 times negative 5 is also positive 25. So that's why we have to have the positive and the negative. So two ways to look at it here to make sure you get the same answer. So if you're doing it this red and blue way, please make sure that you put plus minus 5. All right, so let's go ahead and look at this next problem. I am going to start off by adding 45 to both sides to get my x squared, to work on getting my x squared term alone. So 58 plus 45 comes in at 98. Now I'm still making the goal of getting x squared by itself, so I'm going to divide both sides by 2. And I find x squared equals 49. To get rid of my square, I'm going to take the square root on both sides. So x equals, and now here it comes into play, plus and negative 7, positive and negative 7. All right, let's take a look at the next two problems. We're going to solve these two problems the same way. C has a little bit more in depth to it, but really it's the same idea. We want to start off by getting our squared term by itself. So add 12 to both sides. So x plus 2 squared equals 25. All right, here's where I'm going to take the square root on both sides. That cancels my squared term, and I get x plus 2. Actually, I can probably just drop those parentheses because we don't have anything to do with that anymore. And the square root of 25 is plus negative 5. So now this is really setting us up for 5.5, where we're going to do complete the square. We're going to see some of this pop back. All right, I want x by itself, so I'm going to minus 2 to both sides. So x equals, now we're going to put negative 2 plus or minus 5. This is really splitting it into two problems here. Okay, so this gives us negative 2 plus 5. And this gives us the problem negative 2 minus 5. So here's where we're going to have two answers. We get a 3 and we get a negative 7. So we were having two answers. I'm just going to pop back. We had two answers for these other problems here. We had a positive and a negative 5. We had a positive and a negative 7. Same idea here. We have a positive 3. We have a negative 7. They don't always turn into both positives and a negative, but they could. All right, so let's go ahead and look at letter D. So I'm going to subtract my 48 over, and I get 3x squared equals negative 48. I want the x squared by itself, so I'm going to divide by 3. X squared equals negative 16. All right, so I'm going to take the square root of both sides to cancel out that square, and I get x equals, oh man, plug that in your calculator. So your calculator should tell you like non-real answer, can't do it. And this is where finally you guys, we get to come to imaginary numbers. And that is what we're going to see here. Okay, so I'm not going to go any further. We're going to end here, but just know that this is the next thing we're going to talk about for class. Thanks, guys.